Today we're going to learn how to write a formula for a recursive sequence. In the previous IXL assignment, you just had to find the missing term. In this IXL assignment, you have to look at the terms given and construct a formula. So let's go ahead and dive in and look at the sequence given. I would always start by looking at the difference between the numbers. So if we go from -10 to 2, we know that we are increasing, and we know we're increasing by a factor of 12. Same thing as we go from 2 to 14, 14 to 26, and so on and so forth. We always have to write our formula in relation to the previous term. So the way that you notate that is going to be a sub n minus 1. And we know what's happening between the last term and the next term is that we're adding 12. So in this situation, my formula is an is equal to an minus 1 plus 12. So let's go ahead and test our formula to make sure it works. So if I were looking for the sixth term, so a to the sixth is equal to a to the 6 minus 1 plus 12. We know that a to the 6 minus 1 becomes a sub 5. So I'm going to say a sub 5 plus 12. And we know that a sub 5, because it's the fifth term, is equal to 38. So I would plug in 38, and I would add 12 to this, and my resulting answer would be 50, which is exactly what a to the 6 equals. So our formula works out just perfectly. Let's try another example. Here, as I look at this sequence, I can kind of tell immediately that here I'm not adding or subtracting something. It looks like I'm multiplying by something because I'm going from a whole number and then I eventually end up in a fraction. So what I should do is I should try to see what is the multiple between these two that is getting me to the next number. So as I go from -80 to -16, my numbers are getting smaller, which means I'm definitely multiplying by a fraction. And when I did the math, I figured out the fraction was 1/5. Again, as I moved from -16 to -16 over 5, the fraction that I multiplied was 1/5. So it seems like as I move from one number to the next, I'm multiplying by 1/5. Now that I understand what's happening between the terms, I can go ahead and write out my formula. So again, my formula is going to say a to the n is equal to, and here we're multiplying the previous term by 1/5. So I'm going to say a to the n minus 1 times 1/5. So this does not look very pretty. I would much more prefer if you rewrote the formula as a to the n is equal to 1/5 times a to the n minus 1. So again, these two formulas are essentially the same thing, except here all I did was put 1/5 next to an minus 1 in a set of parentheses instead of using the typical multiplication sign. So let's go ahead and just test out our formula to make sure that it works. So if I were looking for the fourth term, or a sub 4, my formula would be 1/5 times a sub 4 minus 1. We know a sub 4 becomes a sub 3, so 1/5 times a sub 3. And we know using our given sequence that a sub 3 is equal to -16 over 5. So this now becomes 1 over 5 times -16 over 5. And then remember that when multiplying a fraction, we multiply straight across the top, straight across the bottom. So my final answer is going to be a sub 4 is equal to -16 over 25. And if we check that against our given sequence, we see that the fourth term is -16 over 25. So my formula worked out perfectly. Okay, so here we have a bit of a weird sequence, because if we look at our numbers here, they're not increasing or decreasing, they're just going back and forth between the same two numbers. So I'm adding 5 and I get 7, then I subtract 5 and I get 2, then I add 5 and I get 7, then I subtract 5 and I get 2. So in this situation, what we have to realize is that there's no consistent pattern between each of the terms. Instead, there's consistency between every other term. Because we're skipping terms here, when I'm writing out my formula, instead of using a sub n minus 1, I'm going to use a sub n minus 2. So now that we know we're skipping every other term, we have to look at what the relationship is between these two terms. So if I go from my first term to my third term, I notice that the numbers are exactly the same. So in this situation, we're not manipulating the term as we move in between them. So I'm not adding anything or subtracting anything, which means the relationship that I have right here is exactly the formula that I'm going to end up with. So let's go ahead and test out our formula to make sure it works. So if I'm looking for the fifth term, or a sub 5, the formula will become a sub 5 minus 2. And we know a sub 5 minus 2 becomes a sub 3. And we know a sub 3 has a value because of our sequence. So if I come over here to a sub 3, I know that equals 2. So my final answer here is going to be that a sub 5 is equal to 2. And if I double check this, looking at the fifth term, it does equal 2, so our formula works out. Okay, so let's look at one last sequence. I'm just going to go ahead and jump the gun so that we can finish this video up quickly. If you look here, I'm going from a positive number to a negative number, back to a positive number, back to a negative number, back to a positive number. So I can't do that unless if the relationship here is jumping a term. So this is exactly what happened in the previous slide. The relationship here is going from the first term to the third term to the fifth term, so on and so forth. Same thing if I go from the second term to the fourth term to the sixth term. And I went ahead and already took care of the math. I know as I jump from one term to the other term, I'm multiplying by 81. Now that I know what's happening, I can go ahead and put together my formula. So always start by saying a sub n is equal to, since we're jumping numbers, we're using a sub n minus 2 because I'm skipping one term. So I'm going to say a sub n minus 2. And what we're doing between each term is we're multiplying by 81. So to rewrite this like I did in the second slide is 81 parentheses a sub n minus 2. So let's go ahead and test out our formula to make sure it works. So if I were looking for, let's say, the fourth term, so a sub 4, then we would write our formula as 81 times a sub 4 minus 2. And we know a sub 4 minus 2 becomes a sub 2. And looking at our pre-existing sequence, we know that the second term has a value of negative 9. So this becomes 81 times negative 9. And if I multiply this out, I get that a sub 4 is equal to negative 729. And if I check my fourth term, that is exactly what I get. So following this video, there is only one IXL assignment. Good luck and have fun.